Right, so I think you can see my screen, right? Okay, so this is what we have learned last week. Okay, so this is chapter 3. Okay, we talk about function of several variables. Okay, how to plot the graph. In tutorial, we didn't plot the graph, but it's okay. We focus more on the partial differentiations. Okay, so everybody comes up and show me the solutions during your tutorial section. So I think you know how to do it for the partial differentiations. Okay, we still have a few parts, okay, for this chapter. That is the chain rule, okay, chain rule. So chain rule is actually a part of the differentiations, okay, a part of differentiations, but the differentiation is not directly, okay, you have to apply the rules, and usually we apply the rules where we have a function and the functions, for example, this one is a single variable functions. Okay, you use the chain rule when you found that the function in the variable in the functions can be represented by another functions, meaning that this x, okay, can be represented by another functions, and you are going to find the dy dt. Okay, so the first things that you have to do, okay, when you're dealing with this kind of function is you have to form the chain rule equations. Okay, you have to form the chain rule equations. So this is what you have to find. So usually you will write it here, and then look at your look at your y function. Your y functions, okay, over here. Okay, your y functions has a variable x. So you will write down dy dx over here, and the other side, you will write down the dx in order to match the term over here. And this dt, usually you will pick up the variable here. So this is how you form the chain rule for single variable functions. Okay, so when we come to multi-variable functions, the chain rule equation that you have to form is much more complex. It depends on how many variables in your main functions. Okay, so z is your main functions. Okay, so these functions have contain variable x and also the y. So for variable x itself, it is a function of variable t, and for the function y, it is a function of variable t. So when you want to perform the partial differentiations, okay, with respect to, for example, with respect to t, okay, so first thing you have to write down dz dt. Okay, so look at your function z. Okay, so now look at your function z, which is this one. If your functions has two variables, you are going to have two sections. One section you are going to perform del z, del x. The other section you are going to perform del z, del y. Okay, and then look at the function x. Okay, now we move on to function x. Okay, you can see x dx. Okay, so this function has one variable, that is the t. So you are going to perform dx dt. You will see that the dt is always matching with the dt over here. And for the other sections, you have y functions, and this y function has variable t. Okay, so you are going to perform dy dt. So this is how you come up with your chain rule equation for multivariable function. Okay, let's see if you have another function that has three variables. You see, x, y, z. So you are going to have x sections, y section, and z section. Okay, you can see, yeah. So you need to perform del w del x, del w del y, and del w del z. Okay, so usually this part will be the same. Okay, you see, it will be the same. If this is dy, then dy. If this is dz, then dz. And at the bottom here, it will be matching with the term over here. Okay, so this is how you form the multivariable functions. Everybody clear? Are you okay? Can you follow?
Yes, doctor.
Yes, doctor.
All right, very good. Thanks for your response. Okay, so we go to the first example regarding the chain rules. I think you have learned the chain rule before, right? Maybe in the other mathematics subject. Am I right?
Yes, doctor.
Okay, so this one we can go very quickly lah. Okay, so this is example 1.15. So, wait. All right, okay. So how come it is not synchronized? Can you see example 1.15?
No, doctor.
Wait, because my iPad is showing the 1.15, but I don't understand why. Okay, so this is example 1.15, you can see. So given that the z is equals to x squared plus y squared. So now you have a function z. Okay, so this function z has two variables, which is x and y. Okay, so for the x, it is represented by 1 over t squared, and y is equals to 2t cubed. Okay, so you have to find, sorry. Okay, so you have to find dz dt. Okay, dz dt. Yeah. So there are two options for you to do these questions. The first one is by substituting. Okay, substituting the x and y into the main equations. Okay, but here I'm going to show you how to use the chain rule to solve for these differentiations. Okay, so the first thing that you have to do is you must form the chain rule equations. Chain rule equations. So look what you want to find. Okay, you see this is what you want to find. So you write down, okay, dz dt. Okay, what you want to find. Okay, so check your z equations. How many variables is that? So you have two variables, meaning that you need to perform del z, del x, okay, for x variable. And another section is del z, del y. Okay, and then next moving is, okay, I will put a dx here in order to match here. Okay, put a dx here, and this one I will put dy. Okay, so the term that we want is the dz dt, so I will put a dt here. I will put a dt. Okay, so this is how the chain rule equation is formed. So meaning that by using by referring to these equations, okay, you'll be able to solve for the differentiations. Okay, first thing you have to find the del z del x, and then dx dt, del z del y, dy dt. Okay, so you have to find each of it. So write down. So z is equals to x squared plus y squared. Okay, so we need to find the del z del x. Okay, so we can do this thing very quickly, which is equals to 2x, and the del z del y is equals to 2y, right? Okay, very quickly. And the x, okay, what is the x? So the x is 1 over t squared. I can write it as a t negative 2, right? Okay, 1 over t squared. So dx dt will be equals to negative 2 t negative 3. Okay, and for the y, what is y? Y is 2t cubed. Okay, 2t cubed. Right, so dy dt will be equals to 6t 2, right? Okay, so you have got all these terms, okay, from the differentiations. Now we put it in our equations. Remember what is our equations? Our equation is this. Okay, so I have a del z, del x, multiply with the dx dt, okay, dx dt, and then plus the del z del y and dy dt. Okay, so this is our equations, same as this one. Now we're going to replace the term inside. Okay, so del z del x is going to be 2x. Okay, dx dt is negative 2 over t cubed. Okay, and then del z del y equals to 2y. Okay, and the next one is 6t squared. Okay, so you have roughly got the answer, but now you have to replace your t and y, your x and y with t. Yeah. Okay, so you have a dz dt equals to 2x. 2x. X is 1 over t squared. Okay, and then negative 2 over t power 3 and plus 2y. Y is 2y, no, y is 2t, 2t cubed. Okay, 2t cubed. Let me erase it. Can you erase it? No, man. Okay, 2t cubed. Okay, and 6t squared. Okay, so it will be equal to -4 over this one. It will be t power 5, right? T power 5. And then plus, what's the value here? 4. 24. 24t power 5. Okay, so this one will be your answer. Are you okay?
Okay, Doctor.
Right. Okay, so this is how you perform the chain rule. I think I can go through very quickly, yeah? So I will just skip it. Okay, so next I will move on to this implicit partial differentiation. Okay, so this implicit partial differentiations. Okay, so you will apply this implicit partial differentiation when you found that you cannot split the functions away from the term that you want to differentiate. Let me take it as example one here. So now you have a term, you have an equation, this one. Okay, equations. And you want to find the del z, del x. Okay, del z, del x. Huh? Okay, so meaning that you must put your z here and the other variable x and y, right? You have to put it at the right side. Okay, but you look at these functions, z is over here, z is over here. Okay, here also got z. And you cannot split the z away from the x and y and make it perfect to be like this for you to perform the del z, del x. When you find the equations happen like this, and you are asked to solve for the partial differentiations, okay, you have to use the implicit partial differentiation method. So in this method, you have to apply equations. Okay, so the equation is very simple. Okay, this is the equations. Okay, so if you have to find the del z, del x, what you have to do is you take the functions, you see the function, okay, and you differentiate with respect to x. Differentiate with respect to x first, and then divide with the same functions, okay, you differentiate with respect to z. Okay, just like this. Okay, and in front, very important is you must have a negative. You must have a negative. Okay, so same concept is applied. Okay, when you want to find the del z, del y. Okay, so you will differentiate the function with respect to y, divide, okay, with the differentiations with respect to z. Okay, and in front also you have a negative. Okay, don't miss the negative. So when you actually don't need to memorize, because you can see, when here is z, here is also z. When here is x, here is also x. Okay, so this is how you arrange for these implicit partial differentiations. Okay, so we will find the answer for this example. So we have 4x squared z 4, z power 4 minus okay, equals to x. Okay, so this one is the functions. Now we are required to find the del z, del x. Okay, so let's apply the implicit partial differentiation rules that I explained just now. So the first thing is you must bring whatever at the right side to the left. Okay, to the left. So meaning that you will rewrite it as this. Power 3 Okay, bring it to the left side. Okay, so right side would be equals to 0. Okay, so what's the formula for this? Remember, it is negative. Okay, so here is x, so it will be fx divide. This is z, f, z. Okay, so this one is the formula. So what is f? Okay, so the whole function over here at the left side would be your f. Okay, so now we find the fx. So the fx would be 8x z power 4. Okay, the second term don't have x, so it's 0. And next is y squared. Next is 0, right? And next is 1. Okay, so your fx is equals to this. Okay, so how about your fz? Fz. So you can write down your fz is equals to, now differentiate with respect to z. So it will be 16 x squared z power 3, okay, minus 15 y z power 2, okay, plus 0, okay, 0, minus 6z, and then minus 0. Okay, right. Okay, so just ignore this part. This one ignore. Okay, so you got the fx, you got the fz. Now just put them together. Okay, put them together. Put them together. Let me read first how to put them together. Okay, so I will write down as, so the del z, del x will be equals, remember you must have a negative, negative at x z power 4 plus y power 2 minus 1. Okay, so this is your fx. Divide with fz. So fz is 16 x squared z power 3 minus 15 y z power 2 minus 6z. Okay, so this one will be your answer. You don't need to simplify. Just put them accordingly. And don't miss this negative sign. Okay, because many students, they always miss the negative sign. Some of them, they want to put it at the top, meaning that you want to bring it here. So if you bring it here, you remember you have to multiply the whole functions. So it will become negative 8x z4 minus, okay, you don't just put in front of the 8, okay? So you have to minus y squared and plus 1, okay? Include all of them. So 16 x squared z power 3 minus 15 y z power 2 minus 6z. Okay, you can write like this. Otherwise, you must put a bracket. Okay, or you put your negative side away a little bit from your fractions. Okay, so this is the del z del x. Is that okay?
Doctor,
Yes.
the negative must multiply on the upside, not the downside, right?
Semestinya, no. You don't, it is not a must that you multiply. If you leave it like this, it's also okay. Alright, okay. So this is del z, del x. So what happens if I want to find the del z, del y? Okay. Okay, so the equation to find the del z, del y will be negative. Remember, it will be negative. And then f what? Fy divide f z. Okay, so this is how you place, okay, your equations. Okay, so fy, just now we didn't find fy, right? and we didn't find the Fy. So let's see how to find the Fy. So here still have a little bit space. I will squeeze here. Okay, so first term is 0. Next is 5z cubed plus 2xy minus 0 and minus 0. Okay, so this one is the Fy. Right, so we put this Fy here. So the Fy is, see, you don't mix, huh? Or you put it away a bit. Okay, negative 5z power 3. Okay, plus 2xy. Okay, and then divide with the 16x squared z power 3 minus 15 y z squared plus 0. No, only plus 0. Straight away. Minus 6z. Okay, so this one will be your answer. Okay, or you can put a bracket also. Okay, no bracket also okay, but you must let me know that okay you are aware of this negative. If you want to bring it inside, make sure you change all the sign. Okay, right? Is it okay?
Okay.
Do you want more?
Okay, Doctor.
All right. Do you want more example for these partial differentiations, implicit partial differentiations?
Yes, Doctor.
Wait, let me multivariable functions. Or maybe we can go to the example in our tutorial. Okay, because our tutorial include this. Wait, let me get the file, our tutorial. Let's try some questions. Let's save the tutorial questions. I think it's here. Tutorial chapter 3, so you can refer to this one. Okay, we can try question number 6. Okay, you can try question number 6. Snap first. Okay, question number 6.
Yes, it's gonna.
Okay. What's the sound there? Okay, alright, so I will go here. So we go to this one. Okay, we try question number 6. So, wait. So it is given that the A is equals to xy. No equals to what? Xy minus yz plus xz equals to 0. Okay, so this is the question number A. You have to find the del z, del x, and also del z, del y. So we go to the del z, del s first. Okay, form the equations. Okay, so for implicit partial differentiation, and you can see the z. Okay. Okay, this one can separate, but I want to solve it by using the implicit. So I use this one. It will be fx divide with the fz. Okay. You can see the z is here, the z is here, the x is here, and the x is here. So this is how you form, and you have a negative. Okay. So next we find fx. So our f will be this. Okay, all of it will be our f. Okay, so when we're doing the fx, it will be equals to y minus 0 plus z. This is our fx. Next will be our fz. Okay, so it will be 0 minus y plus x. Okay, our fz. So we can put them together. Now, negative fx is y plus z over fz. Okay, so you can write x minus y. Okay, so this one will be your answer. Right. Okay, we move on to the next one. Okay, is the del z del y. Okay, del z del y. So the equation for the del z del y is equals to negative fy over fz. Okay, so we have got the fz. Now we need fy, right? So let's find the fy. So fy equals to x minus z. Okay, so now we put it here. Negative fy x minus z over fz x minus 1. Okay, so this one will be your answer. Okay, this is questions A. Right, can you follow? Okay,
Okay, Doctor.
if I'm too
Okay.
fast, let me know. If I'm too fast, okay? Okay, we go to question B. Okay, question B. So what is the questions? Question B is, okay, now I have x z squared plus 2x squared y equals to 4y squared z minus 3y plus 2. Okay. Then you are required to find the del z del s and also the del z del y. Okay, so before we find the fx, fy, fz, everything, right? Okay, we must move whatever at the right to the left. Okay, so whatever at the right, okay, we have to move to the left. Okay, so x z squared plus 2x squared y minus 4y squared z plus 3y minus 2. Okay, so the right side will be 0. Okay, so now this one is going to be our f. Okay, it's going to be our f. Now we can find the fx, fy, and fz. So I will straight away find 3 of them because we will use them, right? So I'll go to the fx first. So I get z squared plus 4x y minus 0, 0, 0. Okay, this is fx. So fy will be 0 plus 2x squared minus 8y z plus 3 minus 0. Okay, so this is my fy. My fz will be 2xz plus 0 minus 4y squared, okay, plus 0 minus 0. Okay, so I got all of them. Okay, I got all of them now. So I'm going to replace to the equation for the del z, del y, and also del z, del x. Okay, so for this one, it will be negative fy over fz. Okay, fy over fz. So it will be equal to negative fy. So look for the fy. 2x squared minus 8yz plus 3 divide fz. So fz is 2xz minus 4y squared. Okay, so this is your del z del y. Now we move on to the del z del x. Okay, so the equation will be fx over fz. Okay, so what is my fx? So it is z squared plus 4xy. Okay, so this is my fx. Don't mix the negative. Okay, and then fz is 2xz minus 4y squared. Okay, is this okay?
Okay, doctor.
Right.
Okay, doctor.
So we will try more exercise for this chain rule and also the implicit partial differentiation later on in our tutorial section Wednesday. Yeah? So this is all about partial differentiations and all about the chapter 3. Is that okay?
Okay, Doctor.
Okay.
Okay,
So
doctor.
Okay.
we will move on to chapter 4 today. Chapter 4. Okay, so I will draw a line. Okay, so this is chapter 4 now. Okay, chapter 4. Okay, so the chapter 4. What is the title for chapter 4? You remember? It is multiple integral. Okay, so try to understand the title. Integral. Okay, what is integral? When I mention about integral, you might think about this symbol, right? Integrals. When you have multiple, it means that it will be more than one. Okay, it can be 2 and it can be 3. So this chapter is all about the multiple integral, how to perform the integrations. Okay, so we will split these multiple integrals into 2. Okay, one of it we call it as a double integrals. Okay, double integrals. And these double integrals, usually we will use it to find the area. Okay, double integral area. We can use it to find the volume. Okay, volume of a 3D graph. And also we can use it to find the surface area of a 3D structure. Surface area. Okay, so when we want to solve the area, the volume, the surface area, we have to consider this. Okay, the dA. So the dA, okay, can happen for different coordinate systems. Okay, so the dA can happen for Cartesian coordinate system. Cartesian coordinate system meaning that it involves the x and y. You remember, x and y. Okay, and it can also happen. Okay, for polar. Okay, so polar, you know, we are dealing with the r and we are dealing with the theta. Okay, so which one to use actually depend a lot on the structure, on the area that you want to find. Okay, if it is in the round shape, circular shape, okay, you will use this one. If it is like a square shape, whatever, okay, you can represent with xy, okay, you will use the Cartesians. Okay, later we will explain, I will explain more. Okay, so this is the first part, okay, double integrals. Next, we will have a triple integrals. Okay, meaning that you have to perform the triple, you have to perform the integration 3 times. 3 times. Okay, so this one, okay, is not represented by A anymore. It is represented by V because we will be using it to find the volume of a 3D graph. Okay, so same like the dA just now. For this dV, it can happen. You can use the Cartesian coordinate systems. Okay, Cartesian. You can also use the cylindrical. And you can also use the spherical. Spherical coordinate systems. Okay, we will look at it later on. Okay, so I think first of all, okay, maybe we practice first how to perform integrations. Do you still remember how to perform integrations?
No.
No. Okay, so I think everybody, you need to have these things stand by with you. This is, okay. Common derivative and integral list. Okay, so this part is the derivative part, okay, common derivative differentiations that we use in chapter 3. So this chapter we are not going to use this one. Okay, we are going to use the integral. Okay, so this one is telling you that how to perform the integral. For example, okay, when you want to integrate this, you will get an x. Okay, so integration is actually inverse process of the differentiations. You know it, right? Okay, so when you integrate one variable, you will get kx. You integrate this one, you get this. So this list I already share in the author. Okay, so you can download it now. Okay, try to download it now because we might be using this one. Okay, so this one is telling you see how to perform all the integrations. Okay, so this one is polynomial, so we have trigonometry. Cos will become sine, sine will become negative cos. Okay, and exponential and logarithmic functions, what happened? Okay, log will become what? Inverse trigonometry. All these they are more complex. Okay, so all these are the law to perform the integration technique. Okay, you can try to refresh back. Okay, later on we will be using this one. Okay, so take some time for you to download this one with you. Okay, so I will write down some example here. Okay, evaluate. Okay, this is example 1. So let's say example 1. So evaluate. So evaluate this. Integrate 1 to 3. Integrate 0 pi over 4 2x second square y dy dx. Okay, so have you downloaded the copy? Okay, we are going to start now. Okay, so now this is double integrals. What you have to do when dealing with double integrals that you will perform the integration one by one. Okay, so looking at this, you will perform integrations of dy first. Okay, because dy is in the inner part. So you will perform integration on this. Okay, so when you are perform integration, okay, with respect to the dy, okay, x will be a constant. Okay, I repeat that when you want to perform integration with respect to y, x will be a constant. Okay, so meaning that you can take the x going out. Okay, so 1 over 3 I will write. Okay, 2x I'm going to take it out because they are constant. Okay, we don't integrate the constant. Okay, so here we just focus on this second square y dy and dx. Okay, right, so we'll perform this dy first. Okay, we'll perform this dy first. A moment. Okay, we continue. Okay, so how to perform the integration with respect to this? We look at the table that I talked about just now. So what's the table? Second square. Okay, how to perform second square? To perform second square, this is different. Okay, so this will be the formula that you have to use. If you have to integrate the second square u du, you will get tangent u plus c. Okay, tangent u plus c. So we use this one. So it will be equals to tangent, it's not u, right? So it's tangent y. Okay, and since you have the limit, so you have to place your limit here. Okay, and dx still put here. Can you follow?
Cannot.
Okay, now take your scientific calculator. Okay, and make sure that it is in the unit of radian. Okay, so this one is radian. So what you have to do is 2x tangent pi over 4 minus tangent 0. Okay, so this is what it means. Okay, so take your calculator and change it. So what is the answer? Tangent 4 minus tangent 0. So you get 1, right? You get 1. This is dx. Okay, so now we have complete the first integrations. Then we move on to the second. Okay, so the second integration is with respect to the x. And you check here, we only have one variable, that is x. So we can integrate as usual. Okay, so when you integrate this one, 2x. Okay, 2 is a variable you can take up. So meaning that you integrate the x. So what happens if you integrate the x? Integrate the x. So we'll be using this law. So when you integrate the x, dx, you will get 1 over, so because x is power 1, right? So 1 plus 1 equals to 2. And then x, 1 plus 1 equals to 2. You get this one. Okay? You get this. So x squared over 2. And 3 and 1. Okay, you can cancel this one. Okay, so this one will be equals to 3 power 2 minus 1 power 2. Okay, answer will be equals to 8. Okay? Is that okay?
Okay.
Okay, Dada.
Okay, so this is the way of how to perform the integration manually. Okay, and this is how you do it. And in fact, you can use your calculator to calculate the answer directly. Okay, so I will share with you videos. Yeah. Okay, so just type anything in the YouTube. There are many video shorts, okay, about how to use the class V's to do the integrations. If you are using the other model, you can search for your models lah. Okay, we just click one of it.
Let me show you how to find the definite integral using Casio 991EX class Wiz. First of all, let's go for the integral sign. So press on integral. We put the function. You can type any function you want. Let's say x squared. And then put the limits, which is from, let's say 1 to 5. That's 5. And put 1, the lower boundary. And we press equal. And then you get 124 over 3. Remember that you can type any function you want in that area, and you can get the value with one click. Thanks for watching.
Okay, are you clear about this?
Yes.
So this is how you use
Clear.
okay the calculator to find. So in this case, okay, I want you to practice it. Okay, like our case, right? So I want you to press calculator, okay, for this term. Okay, your calculator don't have y, okay, so you have to change the y to x. Okay, don't worry about changing the y to x because they are just representations. Okay, so later on in your calculator, I want you to press integrate. Okay, integrate. Okay, automatically you see the symbol and it is dx. So you insert this second. The second, how to insert? Second is 1 over cos square. If you cannot, you press 1 over cos square. 1 over cos x square. X, and then put a square. So be careful when you're putting the square. You must make sure it cover all the whole cos. When you try to press it, 1 over cos x square. Okay, so this is second y equals to 1 over cos y. Right. Okay. So you press this one and then you insert the integral. Make sure it's in your radian, your angle. So pi over 4. Pi over 4. And then this is 0. So you will get answer equals to 1, right? Can you get this? So you press integrate 1 over, okay, bracket cos x square dx in your calculator. And then insert 0 and pi over 4. Can you get one?
Yes.
Okay, so this is how you use the calculator. And then you can continue for the second one. This one. Okay, integrate, okay, 2x dx from 1 to 3. Just to test it whether you can get that same answer or not. So this one will be 2x, 2x, okay, then 3 and then 1. Okay, so you will automatically get the answer equals to 8. Everybody, you may have to try. You have to try, Okay, have to try. So this is a faster way for you to get the answer. Okay, so make sure you can use it. So when you know how to use calculator in the exam or in the test or final exam, you don't need to show all these steps. Okay, you can straight away give me the answer. So, everybody okay? Is that okay? Okay.
Okay, doctor.
Okay, doctor.
Alright, so we move on to the next example. How to perform the integrations. So integrate, okay, 0 pi over 2. Integrate 0 sine x. Sine x. Okay, and then y, exponent y, cos x, dy dx. Okay, so this is a double integral. Okay, so this is double integral. So for the first integral, we have to integrate with respect to y. So where is y? Y is here. Okay, so this term will be a constant. So move the constant out. Okay, move the constant out. So I will write down and move the cos x out. Okay, so I just leave this exponent y inside, exponent y inside, dy and dx. Okay, right. So now I have to perform the integration for this, but I cannot use, oh sorry, this one is not x, it's not y, it's x. But this one you cannot use calculator. Why? Because this one is not the value. So you cannot use calculator. Still, you have to do it manually. Okay, so how to perform integration for exponent y? So we see, okay, exponent term. Where is exponent term? Okay, so exponent term is this. Okay, you will get the same thing. Okay, you will get the same thing. So, meaning that, okay, you will still get exponent y. And then sine x 0 dx. Okay? Okay, so next we replace the value inside. Pi over 2 cos x. And then exponent sine x. Sine x minus exponent 0. Okay? So exponent 0 equals to 1. Okay, exponent 0 is equals to 1. Okay. So now we proceed to the second integrations. So now you tell me, can I use the calculator now?
Yes.
Yes, you can use a calculator. Okay, so please try to insert this to your calculator and see what's the answer we can get. Okay, if you have to perform this one manually, this one I think you have to use the what rules? What's the name of the rules here? If you have to use, maybe you have to use substitution rules or integration by part, okay, to solve for this. Because you have cos x, you have exponent sine x. Okay, a little bit complex, so you have to apply this standard integration technique. But since here you can use calculator, so I will just encourage you to use a calculator. So use calculator to calculate this. Calculate this. This is cos x multiply with exponent sine x then minus 1. Be careful the bracket. Okay, and then pi over 2 0. Okay, so we get 0.7183. You get the answer?
Yes.
All right. Okay. Let's see. Okay. Let's see what question. All right, so this is the concept about double integrations. Okay, we'll move on to the finding the area, okay, by using the double integrals, by using the double integral. Area by using double integral. Okay, area by using a double integral. Okay, so let me copy the question first. Where's the questions? Okay, this is an example, so I will just copy here. So evaluate. So you have to evaluate this double integral x plus y dA, and here is the R. Okay, R stands for the regions. R. So R is the regions. region. Okay, so the region is the triangular regions. With a vertex 2, 0, 0, 0, and 0, 2. Okay, so R is the regions, a triangular region with the vertex 2, 0, 0, 0, and 0, 2. So you have to evaluate. Okay, so in this question, they didn't tell you what is the limit. Okay, unlike the previous questions, okay, they already tell you what is the limit, so you can straight away solve it. But for this question, they didn't tell you. They just tell you that this limit is actually a region of a triangle with a vertex of this, and this. So vertex is the point of a triangle. So if you plot it in the 2D graph, okay, and label it, okay, so 2, 0 will be here. 2, 0, 0, 0 is here, and then 0, 2 is here. Okay, so these are the vertices of a triangle. Okay, so if I draw it, oops, it will be like this. So okay, so this one will be your region. This is the region R. They tell you the region R. Okay, so you have to define the interval yourself now, the interval. Okay, so to define the interval, we have two techniques. Okay, one is the vertical strip technique. Vertical. And the other is horizontal. Okay, horizontal strip technique. Okay, so we go to the vertical strip first. Okay, so now for vertical strip technique, okay, you have to draw a vertical strip in the region. Okay, this is a vertical strip. Okay, the vertical strip. Okay, so now if you move your vertical strip, okay, at the left hand side, okay, move it, okay, so the max you will stop is over here. Am I right? You will stop because this one is covered in the region. Okay, so at these positions, your x is equals to 0. Okay, now you move this vertical line to the right, so you will stop here. Okay, so at these positions, your x value is equals to 2. Okay, so you can say that your dx, okay, is from 0 to 2. Can you follow?
Okay, Doctor.
Okay, vertical strip, you move your vertical line to the left and to the right, okay, to the minimum positions that is covered by the regions and maximum position that is covered by the regions. So the ds is from 0 to 2. Okay, next, okay, we need to define the y interval. Okay, so to define the y interval, you have to imagine yourself is sitting inside this area. You are inside, okay, and when you look down, okay, you see a horizontal line. Am I right? This is your horizontal line. Okay, so this horizontal line is at the positions y equals to 0, right? This is y equals to 0. And when you move it out, you see the other line. This is not a horizontal line. Okay. So this is a tilted line. Okay. And this line, you have no idea what is the exact value because it is actually represented by a equations. By a straight line equations. So every single value of x will give you different value of y. So it's not a fixed value. So now you have to find the equation for this straight line. Okay, the equation of this straight line. So how to find the equation of straight line? Do you remember? C is the intersection point, right? So how to find the M? So if the M is downward, meaning that it is negative, right? Okay, so we are going to take 2. Okay, 2 is the height over here. Okay, divide with the length of x. So this is 2 and this is 2. So you take 2 divide 2 x plus intersection point is over here is 2. So plus 2. So the equation for this straight line is negative x plus 2. Okay, so meaning that when you look down, you see y equals to 0. When you look up, you see the equation y equals to negative x plus 2. Are you clear about this?
Clear, Doctor.
Yeah. Okay, so now this one will be your dy. dy will be from 0 to what? To this. Okay, negative x plus 2. Okay, so we have defined the interval, okay, for this region. Okay, so now we put the interval inside, okay, the equations. So remember here you are asked to solve this. Okay, so you are asked to solve this one, x plus y. X plus y, you just copy back. Okay, so now look at our interval. Okay, so the interval with value, okay, no variable, value, okay, you put it outside. With variable, you put it inside. You understand? Value, put outside. With variable, you put inside. Okay, so when you're putting those with variable inside, you have to check what is the interval. It's dy, so matching with dy. And this one is dx. Okay, so you have formed a double integral. And now you can solve for this double integral. Do you need me to repeat these explanations?
Yes, Doctor.
Okay, so I will repeat one more time. Okay, so now we are using the vertical strip technique. Okay, so the vertical strip technique in order to define the interval of my double integral. You see, here I don't have the value of my double integral. I need to define it. Okay, questions just tell me that, okay, the interval is actually covered by a region of triangle with vertices of these 3 points. Okay, so I plot these 3 points, I form a triangle. Okay, I form a triangle. Okay, next is I form a vertical strip. Okay, so this is the vertical strip. Okay, the vertical strip. Okay, so this vertical strip, I can move it to the left, I can move it to the right. So for this one, okay, this one, I will move it to the left. Okay, when I move it to the left, I will stop at the position whereby the x is equals to 0. Okay, so for this one, I will move it to the right. Okay, so I will stop at the position when the x equals to 2. Why I know it's equals to 2? Because this is the point given by the questions. Okay, so I know it's 2. Okay, so my x interval, okay, for the whole region will be from 0 to 2. Okay, 0 to 2. Okay, so this will be my dx interval. Next, I have to find the dy interval. So in order to find my dy interval, okay, I have to assume myself sitting inside this vertical strip. Okay, so when I look down, okay, I will see this horizontal line, and this horizontal line is represented by y equals to 0. Y equals to 0, which is this one, y equals to 0. When I move up, I see another line, but I don't have idea about its value because it keep on changing. It keep on changing every point. Okay, so I cannot represent this y with value. I have to represent it with its equations. Okay, so this is a straight line. So I have to form a straight line equations. Okay, which is y equals to mx plus c. Okay, mx plus c. So this is the mx plus c. So c will be the intersection point, okay, of the line at axis y. So will be here, these two. So the line is going downward. So the m will be negative value. Okay, so the value for the m will be, you take the dy, okay, divide with the dx. Okay, no, I don't use dx. I use del y and del x. Del y and del x. Okay, so here is 2. Here is also 2. So I take 2 divide 2. So I get these equations. So I have got the equations. Okay, so now when I look into here, I will say that, oh, when I look up, I see a straight line equation, and the equation is this. Okay, so now I have the interval for my y already, which is from 0, 0 is this point, 0, until the equations of the straight line. And you just copy this one, okay? Negative x minus 2, because you want to define the dy. Okay, so that's why we have this. Now we plug them into the equations. Equation is this, x plus y dx. Okay, so x plus y I write down. Okay, and then I look at my interval, and values I put outside. Okay, and this is dx. So dx is outside. Those with variable x, okay, you put inside. Okay, and this is dy. So dy is here. Are you clear now?
Yes, doctor.
Yes, doctor.
Okay, so can you take some time to solve for this double integral using the technique, okay, that I showed you just now? Okay, try to solve this. So can you use calculator for the first integration? Yes or no? Who say yes? Raise your hand. Okay, yes, you cannot use calculator. Why? Why cannot you use calculator? Because this here you have a variable. Okay, you can only solve when your limit or when your interval is value. Okay, for example, this one value, then you can use calculator, but this one cannot. So you have to do it manually. Okay, so you have to do it manually. So it will be 0 to x. You cannot take out because it is not multiply. It is a constant. Constant, when you integrate it, it will become xy. Xy, constant, when you integrate it. Where is it? Integrate a constant. Where is it? You see? This one. When you integrate a constant, okay, x is a constant in this case. So it will become kx. So in this case, we not integrate with respect to x, we integrate with respect to y. So you have a xy. Okay? And then y will become y squared over 2. Okay, y squared over 2. So you have a negative x plus 2 and 0. And this is your dx. Okay? Okay. Now you replace the value. So what value to replace? So confusing. Look at the variable here. Okay, you just integrate dy. So all the y you have to replace with the interval. Okay, so meaning that all the y will be replaced with negative x plus 2 plus negative x plus 2 square. Okay, minus 0. So when 0 replace inside, right, it will become 0 plus 0 lah. Will become 0. Okay, so we can just ignore this part. Okay, so now you can use calculator to find the answer. You don't need to simplify, you just insert into a calculator, but you must make sure you insert it correctly. Okay, bracket must be careful. You don't need to expand it. For example, this one, you say you want to expand it. No need. Just put the whole thing inside calculator. So try to get the answer for this. Integrate. If you're worried this is too complex for you, you can split it. Okay, you press this part first and then you plus with the answer over here. Okay, you can split it. Okay, it depends on you whether you want to split or not. So let's find the answer. For x multiply negative x plus 2 So I split it. Okay, I decide to split it. 1.333. Okay. Integrate. Okay. This one. So I get 2.666. You able to get this answer?
Doctor, if kalau saya tulis apa ni 2.67 okay ke?
Okay. If you don't want to write so many points here, you can just write 2.67. It's also okay. Can you get this answer?
Yes.
Yeah.
Alright, very good. Okay, so what I have explained just now is solving this one using what? Vertical strip technique. Okay, so we are going to try the same question but using horizontal strip. Okay, horizontal strip now. Okay, so this is now horizontal strip. So I will draw again the triangle. Okay, so I will have a line. Okay, and then my equation is y equals to negative x plus 2. This is 2, this is 2, and this is 0. Okay, so exactly the same triangle. Okay, when we said it is a horizontal straight, meaning that you are going to draw a horizontal line. You see this horizontal line? So now this horizontal line, I'm going to move it down and move it up. So when I move it down, okay, this line, when I move it down, so we can stop here, right? It's a minimum. You can go. So at this position, the y equals to 0. Okay, this is a line, y equals to 0. When I move it up, okay, so it will stop here. Stop at the position, the y is equals to 2. Okay, this line, I'm going to move it up. So everybody agree? You agree? So my dy, I will write down as from 0 to 2. Okay, I write down 0 to 2. Okay. Now we move on to define the ds. Okay, the ds interval. Okay, concept is the same. Sitting inside, you imagine you are sitting inside and you turn left. What you see? You see this line. Okay, this is a vertical line. This vertical line is at the position x equals to 0. Okay, when you look at the left. When you look at the right, okay, you see this slanted line. Am I right? You see this line, the whole line here. Okay, and there is no fixed value because the value, okay, is depend on the equations. Okay, it's depend on the equations. So now the equation, you cannot use y equals to negative x plus 2 because you want to define the dx. Now you want to know what is the x value, because just now you are finding the x value, right? So you want to know what is the x value. What is the x value? What is the x value? So you have to rearrange these equations. X, you move it here. Y, you move it to the right. Okay? So meaning that when you look at the right side, you will see this line, and the equation is equals to this. Okay? X equals to negative y plus 2. Okay. So I will write down my dx equals to from 0 until negative y plus 2. Is that clear?
Clear, Doctor.
Yes, doctor.
All
Clear,
right.
Doctor.
Good, huh? Okay, so now, same thing. I have got my interval. So I want to put it inside, right? So x plus y, just keep it. Keep it, huh? Okay, remember what I told you? I said number, put it outside. Okay, put it outside. So you put this dy outside. Okay, with variable, you put it inside. Negative y plus 2. Okay, put it inside 0. And this is dx. dx, put it inside. Okay, so here is your double integral. If you check with the previous one, actually they are the same thing. Am I right? Check. They are the same thing.
Yes.
Okay, so when you perform the integrations, okay, you will perform the dx first. Okay, you will perform the dx first. Do you want to try this one? It will be the same. So I will do it very quickly. So 0, 2 is the same thing. So it will become x squared over 2 plus yx. Okay, and then you have negative y plus 2, 0, and then dy. Okay, so now replace all the x with variable. Okay, you must be clear which one to replace. Don't replace the wrong thing, x. So it will be negative y plus 2 power 2 divide 2 plus y. Okay, negative y plus 2. Okay, so this one, now you have to perform dy integrations. Okay, so it's the same thing like the one above. So the answer is 2.67. Okay? Is that clear?
Clear, Doctor.
Clear.
Okay, so you want to continue?
Sure.
Can you continue?
Yeah, Doctor.
Can okay, I'll just continue. All right, so we go to one more example. See, we have more example or not? Horizontal strip. Okay. Now we are going to find the area of a region. Okay. So just now we are just defining the interval based on the requirement of the question, because this question said that the region is a triangular region. So we define the interval. Now if we want to find the area of the triangle, okay, we'll be using this formula. Okay, so to find the area, okay, the equation is very simple. You just perform the double integrations, and here will be 1, and behind it will be dA. Okay, so just now it is x plus y, right? Because the question said it is x plus y. But if the question asks you to find area, okay, just now the question didn't say that it is an area. It just mentioned that the interval is within the region. Okay, so here it is going to be 1. Okay, so this is the formula that you have to remember when you want to find the area. Okay, so the dA here, okay, is depend on whether you are applying the horizontal strip or vertical strip technique. Okay, so it can be dy, dx, or dx, dy. dy. So for the same questions, okay, for the same questions, if I want to find the area of a triangle, okay, area of a triangle, this is 2, right? The conventional technique, usually you will find is base, or the area you will use this formula, right? 1/2 multiply with the base, the base, and multiply with the height. Am I right? This is how you find the area of a triangle. Okay, so it is equals to 2. So here I'm going to show you that using this double integral, you are going to get the same answer. Okay, right. So how to do it? Use the formula. So if we are using the vertical streak, remember what is our limit? What is our limit? Our limit is this one, right? If we are using the vertical streak. Okay, so it's 0 to 2, 0 negative x plus 2. Okay, so this is exactly the same like the just now, so I didn't explain again. Okay, here you put 1, so this one is dy, and this one is dx. Okay, so when I solve for this, x1, when you integrate, it will become y. So negative x plus 2, 0, and then dx. 0, 2, so negative x plus 2, okay, dx. Okay, now you press your calculator, and see what happened, what you will get. What you will get. Can you get 2?
Yes.
Yes, so this is how you find the area of a region. And of course, this one, the triangle shape is easy, okay? So that we can simply use this formula, right? But imagine if the triangle is much more complex, or it is not triangle, this is the other shape, okay? So we can use these double integrals to find the area. Okay, we try one more and prove it is right. Let's say we want to find the area of a... Wait, let me erase it. Let's say if you want to find the area of a square. Okay, square. Okay, I did something like this, square. Okay, so if this point is 3, this point is 3, and this point is 2, negative 2. This is negative 3. Okay, using a double integral. Okay, let's find. Okay, double integral, this is the formula. Okay, so let's use horizontal streak. Okay, we use horizontal streak. So when I say I want to use horizontal streak, meaning that I build a horizontal line over here. Okay, and this line, I can move it up. When I move up, I will stop here, whereby the y is equals to 3. And I move down, I will stop here. The y equals to negative 3. So my dy, okay, is from negative 3 to 3. Okay, and then how about my x? Now you imagine you are sitting inside this streak. When you look at the left hand side, you see this vertical line, and this vertical line, or is x value is equals to negative 2. Same value. Here is also negative 2. Here also negative 2. Here also negative 2. Okay, so when you look at the right, it is 2. The x is equals to 2. So I can say that my dy here, no, my dx here is equals to negative 2 to 2. Now you apply it inside the formula. Okay, Both are numbers, so it is fine whether you want to put -3 outside or inside. Okay, so if you want to put -3 here, it's okay. Okay, -2 will be here. So negative, it will be dy dx. Okay, right, dy dx. Huh? So what's the value? Okay, you can press calculator. Here you can press calculator already. So here you will get 3 plus 3, okay, dx, right? So it is equals to 6. Okay, so you integrate. So 6 to -2. You get 24. And unit square. Okay, unit square representing that this is actually area lah. Okay, area. Is it correct? How to find the area of a square? Okay, you find by measuring the length here and measuring the length here, and then you multiply, right? So the area will be 3 plus 3, 6. Multiply with 2 plus 4, 2 plus 2, 4. So equals to 24 unit. Okay, so it's the same thing. Okay. Okay.
Okay, sir.
Okay, I will stop now because if I continue, the next example might be a little bit complex. I think I need to explain more time, so I will just stop here, and I need you to fill up, okay, the attendance in the altar, okay, under the assessment. Okay, so any questions?
No.
No questions, huh? So coming will be our tutorial. So tutorial will be on Wednesday, 9 o'clock, okay, for section 3, okay, and 11 o'clock for section 4. It is okay whether you want to join section 3 or section 4, as long as you join. All right. So I will see you coming Wednesday, and make sure you fill out the assessment in altar before 1 p.m. After 1 p.m., I will just close it. Okay?
Okay, Doctor.
Alright, Doctor.
All right. So thank you very much, class. Okay, have a nice day.
Doctor.
Bye-bye.
Doctor.
Thank you, Doctor.
Doctor.
Thank you.